When adding and subtracting with binomials on the bottom, if you can factor first, it's going to make your common denominator a lot nicer. For example, right now in A, if you tried to make a common denominator with these, you would get a very large common denominator in the end. However, if you factor first, say, hey, the first one is x plus 7 and x minus 7. The second one is x plus 7, x plus 7. Then when looking what's missing to make a common denominator, the first one's missing one more x plus 7. The second one is missing one more x minus 7. So your common denominator has three factors: x plus 7, x plus 7, and x minus 7. Are you okay if I do the top in one step? Can you see that you're going to get 7x plus 3x, which is going to give you 10x. If you distribute the 7, I'll have 49 minus 21 plus 28.
This is going to be like all non-calculated, right?
Yeah. What was hard there without a calculator? 7 times 7? 49 minus 21? Not too bad. And then we have to check to see if we can simplify this any further. So we factor the top again. Can you see that there's a common factor of 2? Does anything simplify away? You could put x plus 7 squared. That would be fine. But there's nothing that factors out. So we've added, and we're done. Part B. Again, always factor first. N plus 6, n minus 3. And n plus 5, n minus 4. Whew. What do you notice? There is an n minus 3 here and here. That could simplify. Then we would have 1 over n plus 6 minus n minus 2 Why can't we add these right now or subtract these? Multiply it out? Well, we always want to factor first.
Oh, yes, multiply.
So that would sort of undo what we just did earlier. Because we factored it so that we could find our common denominator faster. And in this case, it allowed us to see that something could be simplified first. If you can simplify things early, it makes your life easier. Because now with the common denominator, I see that this one is only missing the n plus 6. And this one is missing both the n plus 5 and the n minus 4. Oops, go black to black. So our common denominator, we have n plus 5, n minus 4, n plus 6. And in my first one, if I multiply that out, I'll have n squared plus n minus 20. Subtract, same common denominator here, n plus 5, n minus 4, n plus 6. And if I multiply the top out there, n squared plus 4n minus 12. We have to be careful here because we're subtracting. That means we would subtract all of that. So our final answer, common denominator of n plus 5, n minus 4, n plus 6. I have n squared minus n squared. Those will go away. I have an n minus a positive 4n. That will give me negative 3n. And I have a negative 20 minus a negative 12, which will give me negative 8. The top cannot be factored. You could take out a negative 1 if you wanted. It's not identical to any of the factors in my denominator. So at this point, we're done. We've added our fractions, which meant we got a common denominator. We combined all of our like terms. Nothing more simplifies. Yes?
I thought you said you're not supposed to unfactor.
In your denominator. But in your numerator, since you need to add them together, you have to expand them so that you can combine like terms. Questions for practice right now, 6, 7, 10, 12, and 13.